All right then, we're live. I hear somebody in my other chat room. Hey, it's Z. Critter says good afternoon, Z. All right, you know what? I'm going to log out of my IRC client and I'm going to log back into my web client. There we go. Got both clients up now in Russ's web page. So Ortoria, as I explained in my last email, I think the conditions that I'm observing are entirely explainable and to be expected. The ZVS circuit was a parallel driven circuit. That's why I had lowest current without a workload and highest current with a workload. This circuit is parallel. And I can still drive it parallel. I just need a primary and a secondary, right? Right. I don't need I'm gonna deviate here from the I'm such a deviant. I'm gonna deviate from the normal configurations that we've seen. I'm gonna try something a little bit new. I have a feeling this is going to work. I'm sorry, I cannot stand the clutter on this bench again. I'm just going crazy here. Really, this drives me nuts. What's the temperature in here? We're up to 62 degrees. Yeah, I guess I'll throw another bucket of pellets in there. Been been going through quite a few pellets this year because I'm spending more than usual amount of time down in the workshop. Also, I started to say, Ortorio, do you agree or disagree with my statement in the email? I'm eating PBJ. I burned about 12 bags this year. Yeah, I'm up to 6. I just finished my 8th bag for the year. Now your consumption rate is higher. You have a bigger space to heat, so you're probably not out there as much as I am in here. How goes the pellet basket modifications? And Alan, you're absolutely right. I should explain to the rest. Ortoria sent me an email and stated that she felt that there was something crooked with my results, where I was getting more current with no workpiece in the coil versus less current with the workpiece in the coil. And my reply to her was, I would agree with you, except the circuit that I'm using now is a series-driven resonant tank circuit, not a parallel-driven resonant tank circuit. The ZVS circuit that I started with was parallel-driven. So when there was no workpiece in the coil, impedance was highest and current was lowest. With a series-driven resonant tank circuit, impedance is lowest at resonance, and the Q factor is highest. When you insert the workpiece in a series resonant tank circuit, the Q factor drops, hence the current drops when you insert the workpiece. The circulating currents are highest when there's no workpiece in a series resonant tank circuit. That's one of the benefits of going parallel driven. You don't present a load to the output circuitry unless there's a workpiece in the coil. And I will be again going to parallel driven tank circuit, transformer coupled. That's one thing I have not seen anyone do online. I have seen parallel driven with matching inductors using LCR. I have seen parallel driven directly from the output of a ZVS driver, but I have not seen parallel driven transformer coupled. And personally, I think it just makes sense. So we're going to try it. This stove is incredibly hot right now. Wow. I got 950 at the top, almost 600 on the side. Wow, that's hot for the side of this stove. 600 on the side. 500 down low on the side of my stove, and 244 out the flue. So parallel would be better. I think so. I agree. I think parallel would be better. I think it's inherently self-protecting. Right? Schematics of the original ZVS circuit. You know what I'm doing with these? That's what they're worth. Excuse me. have I got plugged in over here? Too many. Way too many. So I'm pretty sure that the impedance matching inductor method, LCLR method, probably would have worked if I better understood the impedance transformation formulas for the various inductance values that you need to use in that circuit. Yeah, so every once in a while I just need to reset my bench because it gets so crowded and cluttered that it drives me crazy. I can't stand working that way. Now this is a cool little gadget. Z130LA10A. This is a instantaneous resettable fuse. Looks a lot like a capacitor. Ding dong. Work email. Ding dong. She's alive! Sorry, couldn't resist. So I watched a half-decent movie last night. Wasn't quite as good as I had hoped, but then again, you know, I'm not a Marvel Comics aficionado, but I saw Doctor Strange last night. I thought it was pretty good. The special effects were very, very good. Okay, so that load of pellets should get us up to almost sauna-like temperatures here in the workshop. Oh boy. The email are flying at work now. I wonder what it's about. 6 new messages. Look at that. All from the same guy who never sleeps. Why can't I reply? The fuck? Okay. I've just thrown one of our prime vendors under the bus. For dragging their feet for not fixing a problem that we have been reporting for quite some time. Oh, and do you know why we're having this problem? Because it's a Windows-based device! What a surprise! Have I mentioned to anyone recently how much I hate Microsoft? Have I? All right. Now I can work. What happened yesterday? Stream was bad. I had to leave. There's another Microsoft issue. What happened yesterday was my youngest daughter was using a Microsoft-based, or I should say a Microsoft-acquired property, Skype, on our home network. And like most Microsoft products, it wanted to hog 100% of the bandwidth resources, even though it didn't need it. And this went on for 2 hours. Until she closed her Skype client and everything just returned to normal. Damn that Microsoft? No, fuck Microsoft. Fuck Microsoft. I hate Microsoft. Have I mentioned that I hate Microsoft lately? Yeah, Microsoft. Fuck you. Unbelievable. Just can't make the shit up. You know what I'm saying? Just can't make it up. All right, so we're going back to parallel driven tank circuit, transformer coupled, which is a new twist that I have not seen anybody do. Let's see if we can make this work. So a Ubuntu device for all Skyping at the house is in order. Yes! Although, I still wouldn't use Skype. What I will say is Jitsi has been under very active development lately. Over the last couple of weeks, I've received at least half a dozen updates to the Jitsi client, so I'm anxious to try that again. And if it works reasonably well, then I would like to very publicly start recommending Jitsi in favor of Skype. This stove is dying down. I might have too much ash in my horizontal burn tube. Maybe time for a cleaning. But not right now. Not right this minute. Unfortunately, the other end of your daughter's conversation will need it. Yes, I know. And I have the contact information for the other end of that conversation. I think she is open to trying something new. Because she is as anti-establishment as anyone you've ever met. And Microsoft is the epitome of the establishment. So Adirondacks, I was looking for you the other day because I wanted you to tell me what the URL was for the new Putlocker website, but I ended up finding it. It's putlocker.ch. And I watched a movie last night, Doctor Strange. It was pretty good. It's pretty good as Marvel comics go. Good casting. Yeah, I agree. Microsoft is a parasite. He played Sherlock Holmes in a series. Yep. He was also in that movie, The Imitation Game. He also played Khan in one of the Star Trek movies. He's a very good actor. Shaziz is in the chat room. Wow, look at that. Do I have Amazon Prime? No, why? I will not pay $99 a year for the privilege of using a service. Man, that rocket stove is going crazy. I love it. I just love it. Yeah, I agree, but they do have monthly option, $10 a month. They have every movie and TV show known to man. Also unlimited cloud storage. I'm checking it out. Huh. Okay, well, you can check it out on my behalf. How's that? And of course, when you say they have every movie known to man, you still have to pay for it, right? Or does every movie known to man come with the price of your price of admission? Comes with the price of Prime. Oh, okay. Well, that's different then. So they're competing with Netflix. I like that. Thomas A. Anderson. Wow. Hey, Neo. Welcome. Welcome to the Matrix. Plus, if you get stuff off Amazon, the shipping is unreal. And yes, an alternate for Netflix. There are millions of us. Finding one is like finding a needle in a haystack. Yeah, right. I see that Scarecrow's website has changed. I haven't gone to the website, but that doesn't surprise me because he is now going to be live. Let's see, that's just an indicator, right? Yeah, Scarecrow goes live tomorrow. Scarecrow will be doing a audio-only broadcast every day, every weekday, on the Rense Radio Network. And he will again be, quote, barking at the moon as if anyone was listening, end quote. All right, I need to go dump my wastebasket. Right back. Yeah, it's cold out there. But it's toasty in here. Shubis will be tuning in. Z might like it too. What? What's very funny? Mr. Anderson. Oh, Mr. Anderson will like this. Hold on a second. Let's see. The Alternative Minds, a glitch in the Matrix. Thought I had. Tom Sanderson. There's the glitch. A Sequential Pictures production. Whoa. This audio track is really soft. Okay, well, this is cute, but I don't have time. Blame Shaziz for me being here. Okay. All right, Shaz, what the hell? And to answer Shubis's question, is it warmer in here than it is where he is? It is, well, the thermometer hasn't quite caught up to the temperature rise, but where the thermometer sits right now is 76 degrees Fahrenheit. I'm guessing it's closer to 80, and I got a little bit left in the pellet basket to burn off, plus some residual heat to get rid of, and the hysteresis of the temperature gauge, the temperature probe. So I'm going to say, yeah, it'll probably settle out at about 80 degrees in here. It's 21 degrees outside right now. Outsider says good audio starts 5 minutes in. Yeah, I still don't have time to watch it. Yeah, looks funny. Yeah, it's nice. All right. Yeah, Shubis. Which stuff? I keep my passwords I keep my passwords in a TrueCrypt encrypted vault. Critter, call me when he is melting shit. Huh. Wow. Wow. You think you know somebody, huh? Boy. Boy, oh boy. Your journal can be confiscated. Not only are my passwords encrypted, but they are stored inside of a hidden volume with a very secure password that I have never used anywhere else. and never exposed on any computer that has ever been connected to the internet. So I have plausible deniability. So, white is channel 1, red is channel 2. I'm talking to everyone who's been discussing storing their passwords. Shubis started it. It's all his fault. I cannot believe how hot the side of this stove got. Wow. Error 1. Oh, nice. My brand new infrared thermometer has crapped out. It is giving me error 1. Isn't that special? Isn't that special? All right, well, I'm not at that point yet, but if it doesn't come back when it cools down because it got a little hot being in the... I'm thinking it may be because it got a little warm being too close to the rocket stove. We'll see. So if I've got a 0.29 ohm impedance for my tank coil, and I want a transformation ratio of say 10 to 1, I need a turns ratio of about 3 to 1. I've got 15 turns on the primary, so 5 turns on the secondary. Let's start with 1. Two. We'll start with 3 turns on the secondary. That's a 25 to 1 impedance ratio. .25 to 1 impedance ratio, so 0.29 times 25 would be 7.25 ohms. 30 volts would be 900 divided by 7.25. So 30 volts would be 124 watts. That'll be a nice start, a nice easy going start. Let's see. Heidnik says try new batteries. I did try new batteries. That did not work. Couldn't handle the heat. Wonder if it would do the same thing on LT Spice Simulator as it is doing now. Probably. Is there a schematic for this? Nobody here but us chickens. You drop something, but it does not go. So Z, what is the ultimate goal of this project you are working on? The ultimate goal of this project, this is just this induction heater is just the precursor. Is one of the tools that I need to conduct the experiment that I'm working on. The experiment that I'm working on involves what's called non-Julian magnetostriction. It is a non-symmetrical volumetric changing alloy that I wish to create, comprised of 83% iron, 17% gallium, that when placed in the presence of a magnetic field expands in volume about 30%. I am considering using this alloy as an actuator for a rotary embodiment that will react in the presence of permanent magnetic fields. The premise of my design is that well, we'll start at the beginning. If you have a magnet in motion, and that magnet in motion passes by a piece of steel and induces a magnetic field into that piece of steel, a couple of things happen. If there are no eddy current losses, then the attraction force in both directions should be equal. In other words, as the magnet approaches the ferrous structure, it will accelerate towards the structure, and as it departs and recedes away from the ferrous structure, it will decelerate once again, equal to the acceleration that it experienced when approaching. If there are eddy currents, then there is a braking force. The alloy that I am making, not only does the alloy that I'm making expand in size in the presence of a magnetic field, but it has virtually zero hysteresis, meaning there are no eddy currents being induced in this alloy in the presence of a changing magnetic field. My supposition is, if I can use this alloy as an actuator on a crank to continue the rotary motion of a rotary engine, we may have over unity. We just might have it. Or what would be classically defined as over unity, which probably is not, but I could definitely say that it would be the extraction of energy from an as yet unknown and untapped source. So yeah, I'm pretty excited about this one. This is the premier experiment that I have been wanting to conduct for a couple of years now, and this is the first time that I have been really quite serious about it, and I have all of the raw materials that I need to conduct the experiment. I have my carbon graphite crucibles with cover. I've got a couple of these. I've got the carbon molds that I'll be using to cast my my bars with. My stirring rod, carbon stirring rod. I have some other ceramic, long ceramic cigarette-shaped type molds coming from China. Those have not arrived yet. I expect those sometime, actually maybe sometime next week by now. And hopefully everything will be ready and in place by the time I'm ready to create the alloy to make these actuators. So yeah, that's what this is all about. The error that was given by my infrared no, I forgot how to turn the laser on. Shit. There we go. All right, so yeah, my infrared thermometer, the body of it was getting too hot next to the rocket stove. And that was perceived as a malfunction of the device itself. All right. Now, moving on, there is a couple of small changes that I'm going to be making to the circuit. If anyone is interested in seeing the actual circuit diagram and the changes that I've made, please let me know, and I'll stop for a minute and upload a PDF exported file to my web server. What required temp do you need? I need 1500 degrees centigrade to melt the iron. I need to be able to accurately measure 730 degrees Celsius, which is the Curie temperature of iron. Once I reach a temperature of 730 degrees, then there's a slow cool down process that is required to treat the material before utilization. So my infrared thermometer has a maximum temperature of 1050 degrees Celsius or centigrade. I should stop using those terms interchangeably and just pick one, right? Is the final product an alloy or just a comment? Oh, Jesus, Gary. Outsider, you're not banned from my channel. Anyone else having problems logging into my my IRC chat? Okay, I just logged into my own chat. I just logged into my own IRC chat as a guest. I don't quite know what guest number I am. Let's see, change nickname. Disconnected from server, repeats over and over. Closing link. Z-line, your host is listed in a DNS blacklist. This ban is automatic and may be in error. If you wish to appeal this, your host is listed in a DNS blacklist. This ban is automatic and may be in error. Blah blah blah. So is 68.18.197.180 your IP address that's been assigned by your ISP? Okay, so it's the IRC server saying you are on a DNS blacklist. Wow. That just happened too. I don't know what to tell you, dude. There's only one user that I have blacklisted, and it's a Comcast.net address. All right, I've got some questions here. But he needs 1500 degrees C. How will you prevent separation by density? Wouldn't the magnetic field disturb the structure of the molten material? Okay, let's answer the questions one by one. How do you prevent separation by density? You don't have to. Molecular motion keeps it mixed. Wouldn't the magnetic field disturb the structure of the molten material? No, because above the Curie temperature, magnetic fields have no effect on the molten material. If you let it just keep trying, it will let you in. Oh. Guest number 6798 says, if you let it just keep trying, it will then let you in. What is the IP? My IP is in the Whois. Outsider's IP address. Ah, shit. That's Outsider's IP address. Now, Gary Langwell is also washington.comcast.net, so you're both using the same ISP from the same area. That's crazy. That's crazy. I have no explanation. Sorry. I know. It's a glitch in the matrix. There you go. We're not really here. Yeah, I know, right? Yeah, so Shaziz, if you look up non-Julian magnetostriction at Revolution Green, revolution-green.com, Mark Dancy did a couple of articles on it, and there's a published white paper at nature.com. I have a copy of it if you'd like to see it. It's very interesting reading, I'll tell you. And I shouldn't say I have always contended, but I have recently begun to contend that the true key to unlocking the wheelworks of nature will be in nanotechnology and elemental substances, which is what we're doing right now. This is alchemy, right? This goes back to thousands of years ago. People probably knew of this thousands of years ago. Civilizations probably rose and fell long before our discovery of this phenomenon. It was probably a black art. Nuts. I knew I was dreaming. You were dreaming. Cool, I would really love to check it out, and I agree with what you just said. Oh, about the knowledge being, about it being known and hidden. Yeah, absolutely. Absolutely. There's so much knowledge that has been hidden from mankind, only to enslave us. Guess what? Shackles are coming off. So I hope everyone was paying attention to what I just said about my proposed model, because I really think it's going to work. I would not invest this much effort into any project if I did not think it was going to work. Let's just start with that right now. All right, let's get that out of the way. I mean, as cool as it is to make an induction heater, that's not the reason I'm doing it. I'm not doing it for cool. Part of my problem with being crowded on this bench is I have this power supply front and center, and it really doesn't need to be. So I'm going to change the location of my power supply and move it to the back corner of my bench here. Like so. Wow. I've had this thing charged up to 30 volts the whole time. That could have been very bad. And look at this. I have actually got room to work. Wow. It's a beautiful thing. All right, let's do this. I really wish I could have music playing. Yeah. It's so annoying. If I had an IFB, I could have music playing like Russ does in his earpiece, but again, there's no background noise, no background music for you guys to hear. And a lot of times I just sort of zone out, and I do apologize for that when I do that, but you know how it is when you get in a zone. Let's move this up here. Move this down here. T equals time might be an issue. Still sounds like it conflicts with the laws of nature. Let me tell you what conflicts with the laws of nature. The very fact that this metallic alloy expands in volume in one direction only. All right, magnetostriction, the principles of magnetostriction are well understood. The principles of Julian magnetostriction, to be specific, are very well understood. Okay? If a magnetic material expands in one direction, it contracts equally in the opposite direction so that the overall volume of the piece remains the same. The properties of this alloy deviate from that 180 degrees. Instead of expanding in one direction and contracting in another, it just expands in one direction. It changes volume, and the rate of expansion is almost equivalent to the motion of a solenoid plunger. Think about that. The rate of expansion is almost equivalent to a solenoid plunger. Think about the work that you can do with that molecular motion inside of an alloy that has no hysteresis. That's a phenomenon called non-symmetry, and generally speaking, You don't find non-symmetry in nature. What you find are laws that say if there is an action, there will be an equal and opposite reaction. This does not conform to those laws. It's a lawbreaker. Could be a change in density. Technically, yes, because you have the same weight but different volume. So yes, the density goes down. That is absolutely true. That is absolutely true. Think about that kind of world. Think about that kind of world. I've thought about it for decades. I think it's pretty safe to say that everyone assembled in this room, in this chat room, has pondered that at length. Probably there will be a hidden catch. Well, if there is, I'm going to find it. What I would like to be able to announce on YouTube is that Blood for Oil is over. A machine like this would fundamentally change the course of human history. And if I'm the one to find it and release it, then I will then know what my purpose on Earth was. Oh, once it's out, Whistler, or White Star, once it's out, there's no taking it back. As far as I'm concerned, it's already out, all right? Anybody who watches this video later when I publish it. Purpose? Pour a cold one. What? Sorry, I don't get it. All right, let's see. That's that. Now, I need a jumper resistor from. 47K. 47K. Let's see if I got one in here. Or 51K. Either one will do. $470. $27.15. There's a 47K that's been beat to snot. I guess I can use that one. $47K half watt, don't want that. Alright, so for the purpose of getting this done, we'll use a carbon. And for those who are not aware what I'm doing, what I found was when looking for information on why people were having trouble getting phase comparator 2 of this 4046 chip to lock on frequency, a number of people in some forums reported that it had to do with the different type of output circuitry that phase comparator 2 on the integrated circuit chip uses. Apparently phase comparator 2 has a tri-state output, which is forced high, forced low, and open, which allows it to float. And in a non-locked condition, the output is open as opposed to high or low, which in that state is high impedance and subject to interference from noise. And that has been my problem. So the solution is simply to bring the output to 1/2 of your regulated input voltage when the tri-state is open. And that lowers the impedance of the output to about 22K. And that should be low enough to suppress any unwanted transients getting into the circuitry. There were a number of representative oscilloscope traces shown as evidence that this may very well be the problem that I'm having. And it's ready to test. I like free energy over unity. And Heidnik, it has nothing to do with Outsider in Russ's chat room. It was Outsider in my chat room. IdleChat.net was refusing his connection. Oh, Jesus. Heidnik, God damn it. Damn you, Heidnik. Watch this. Watch this. No way. Wow, today's my lucky day. Yeah, we're not getting anything out of the magnet. We're not looking to get anything out of the magnet. We're looking to get mechanical motion out of the alloy. It's the alloy that's the key here. The alloy simply behaves a certain way in the presence of a magnetic field. Hey, I stole your 6. Yeah, right. I retire as a dice thief. All right, so I'm going to start slowly. We're going to power this unit up. We're going to look at the output without connecting the driver. We're going to attach pieces one by one and see what happens with each step. And at this point, I think it's time I think about putting together some sort of camera mount that I can show my scope with. So if you'll excuse me for just a moment, I'm retiring to the TARDIS. To see if I can find those gooseneck mounts that I was talking about. I'll try to whip something up quick that's similar to what Russ is doing, because I really like, oh, is this it? Yes. There it is. But this is not what I wanted. Oh, I know. Ooh, yeah. I'm going to sacrifice one of my Motorola microphones. That's the ticket. That's the ticket. Oh, hell yes. So I know that one's working. Now, this is a flexible camera mount if I have ever seen one in my life. Today is the future of yesterday. Well, thank you. If you drop 2 drops of water, one with Diet Coke, the other with dish soap, on a plate and test it with it hacks exactly like a diode, really. Only works while the water is present though. Once dry, it stops working at all. They have to be touching but not mixed. That's interesting. Well, water is polar. Ken's website got a mention. Ken who? Oh. Yeah, what the hell's his last name? Yeah. I converse with him from time to time. Yeah, it's pretty sad how many people took credit for other people's work, isn't it? Well, I think I found out why this microphone doesn't work. Only one wire was attached. Excellent. Now I have a replacement electret element for my other gooseneck microphone. Almost there, guys. Almost there. Wrong camera though. Where's my close-up cam? Ah, there it is. This will save me from having to put the tripod on my bench while I'm working, just to show you the oscilloscope. This is good. This is very good stuff here. Magnets. Anything magnetic? Oh, it is magnetic. Damn, that's nice. Wow. Someplace around here I've got some magnets stuck. There's one. All right. That's another one. Jesus, wow. I've got a lot of possibilities for mounting now. So if I take that and screw it to there, yeah, I have this habit of storing magnets in places that I forget. I need to stop doing that. Close. Bingo. Oh man, this is perfect. Black mark on your thumb from magnets. Yeah, Neodyms will do that to you. I've got a whole stack of Neodyms that were given to me. 1 inch by 2 inch by a 1/4 inch thick. They are N57s. And they are strong as hell. I have shattered a couple of them already by allowing them to come together too fast. And when they shatter, they explode. Drill bits. It's going to be close. This is going to be close. What happened to my nut? It's just here. Losing it. I'm losing it. I just used it. Oh. Wow. All right. So, one nice thing about drilling a piece of metal that's right next to a magnet is the magnet collects all of the chips for you. And of course the drill bit size is something in between 5/16 and 3/8, so I'm going to have to pull out my big drill index. Because it's a metric. Thankfully I have this nice big drill index. And once again, the neodymium magnet was nice enough to pick up all of my metal chips for me. First things first, one of those metal chips poked itself into my finger. There we go. And I guess it is 3/8 of an inch. Oh well. Come on. There we go. Huh. A little bigger than 3/8 of an inch. Okay. Next drill size up. I have to be careful to go in very small increments because if I don't, the hole will just slip over the collar of the gooseneck. Now we're talking. Shit, I can almost thread that on there. Right, that's close enough. Oh, sweet. Alright, so all I need now is to put this nut on here, catch a couple of threads, And voila. I got me a camera mount. Albeit a pretty flimsy camera mount, it is a camera mount just the same. I might have to make this base just a little bit heavier. All right, let's see how this works. My USB extension cable is around here somewhere. It is attached to this camera. Okay, let's get rid of that view, open up that one, which should be that device right there. Nice. Now I can take this, slide it over that way, and you got a nice shot of my scope. Beauty. channel 1 and channel 2. Get her done. Yeah. How about a drone program to do the room and stay above head level with camera on a fixed target? How about not? Yeah, just need the landing pad. On what, on top of my head? Oh man. Are you drinking? Because if you are, I need to catch up. Root says I am. All right. Hot damn. That's right. Hot damn. 100 proof. The real hot damn. Let's see. It's illegal to fly a drone just anywhere without owner's permit. Actually, there was talk about requiring a pilot's license. We were looking at using a drone to cover the Manchester road race, but it's not legal to fly a drone over the public because too much shit can happen. It's not a bad idea, though. It is a bad idea. It's a very bad idea. A, I wouldn't trust it. B, it makes too much damn noise. Come on, man. Are you kidding me? All right, so we're not going to attach the current feedback loop. We don't need the reset. I'm going to try to get a phase lock and open loop adjustment on the scope. So here we go. White probe channel 1. This is ground, and this is output. One of the, yeah, let's look at them both, why not? Why the hell not? All right, so there are my two outputs. Looks like I'm getting a little bit of drift on channel 2. That may be the result of not thermally coupling those two 2N2222s. All right, 10 volts per division on each one. DC coupled. And survey says there is my open circuit output. At 5 microseconds per division. I'm triggering on channel 1. You guys are so funny. Okay. Now the voltage that I see at the sources there's the voltage that I see at the source of gate 1. Gate 2 and 4. All right. So there's my crossover. Right, we have zero conduction in the transition zone, so we don't have any short circuit. I'm off to take a nap. I need some beauty sleep to counteract this face I'm having to carry around. Oh, come on, man. Yeah, you do have a face made for radio. Sorry. Sleep well. A jewel necklace. He's so funny. All right, it's time to hook up the tank circuit. Everything looks good, even though I don't have a phase lock because I have no signal input, and I don't understand why the LED is on, indicating that I have a phase lock. That's what troubles me. You know, damn. If I ground the signal input, what happens? There. Oh, nice. Okay. Oh, shit. If I can just get it to stay that way, I'm good. And so my set frequency is There. Five, 10, 15. There's 54 kilohertz right there. 18 microseconds. Y to the x minus 6 equals, no, 18 y to the x 6 minus equals, no, 18 y to the x where's my plus minus? Oh, there it is. 6 minus equals. There we go. That's wrong. That's very, very wrong. Fifty-four 0, 1 over x kilohertz should be 0.00018.5. So let's see, that's 1 millisecond. That's 1 microsecond. So it'd be 18.5 microseconds. I have 5 microseconds per division. That's 18. .5 microseconds. Okay. So there's my center frequency. That's what it needs to be. I am not in a phase locked state. Oh, I don't know how my calculations could have been so far off, but anyway. Now it goes without saying that I'm attaching these wires to my capacitor bank as my feedback loop for the phase lock loop, as the feedback for the phase lock loop. It goes without saying, I have a 50-50 chance of getting it right, and it will not come up right the first time. Of the last 6 times I have demonstrated this 50-50 odds, it has not come up in my favor once. And that's pretty typical. That's pretty typical. 50-50 odds means you will get it, or at least it means I will get it, maybe one time in 9. If I'm lucky. Mark the damn wires. Well, that's great if I know where I'm starting from each time. But I've just completely torn everything apart and started over again. So I don't know what the correct phase is. Once I have the phases correct, yeah, I can mark the wires. But why bother? It's fun being wrong all the time. Right? I don't know. Like someone said in chat, must be bad karma. Or bad juju or whatever. I mean, look, I'm 0 for 15 trying to get a decent call sign. 0 for 15. The record, as far as I know, from what guys on the AE7Q forum are saying, the record is 0 for 19, and I'm closing in on the record. Your marriage should be used to it. Yeah, right? Ouch. Ouch is right. Yep. There is some truth to that, however. Oh well. You play your cards, you know. All right, so I've rolled the die. I've rolled the dice. I don't know, I forget which one is plural. Actually, no, I've not rolled the dice. I've flipped the coin. Heads I win, tails you lose. Or heads I lose, tails I lose. Okay. And attach the transformer. Right. And I'll put my scope. What do I want to scope? I guess I will just scope this. Actually, this is fully isolated, right? So I can scope this and I can scope what else? What else do I want to scope at the same time? Yeah, that's all I need. All right, here we go. We're at half power, roughly 15 volts input. $20 volts per division on channel 1. Power onto the driver, power onto the PLL, no lock. Of course not. I will reverse the feedback leads. Turn the power on, and still no lock. Which begs the question, why? Let's start a little higher. Bandwidth is not too narrow. Let's see what I've got for a signal on channel 2. Channel 2, what do I want to look at? I want to look at pin 14. Let's see, 16, 15, 14. Right there. All right, so channel 2 is going to look at the input signal to pin 14. What the hell? Oh, my ground fell off. And we'll go to 10 volts per division there. Yeah, I had a feeling that was you, Larry. Is the wave on channel 2 supposed to be cut? The input biasing circuitry of the 4046 does that. Actually, I'm not looking at pin 14, I'm looking at the junction of those two diodes. I wonder if one of those diodes is bad. Let me look directly at pin 14 here while I do that. Here is pin 14 directly. Something is not right there. Although that is the internal bias. You see it clip and then it doesn't clip. Maybe I don't have enough signal coming back. Because it's really supposed to be strong enough to clip. I can try turning up the voltage. That doesn't help much. One thing's for sure though, I got a nice clean sine wave on my tank circuit. I'm happy about that. All right, I've increased the voltage, but I haven't changed the phase. Let's try flipping the phase again. So for each change that I make, I need to try both phases until I get something, until I see something promising. I'm trying to think if there's any reason why I shouldn't. I mean, everything is transformer coupled. This tank circuit is like completely isolated. I'm trying to think if there's any reason I shouldn't ground one side of this tank now that I have it transformer isolated on the drive. And there really isn't. So let me try bringing the feedback into the phase lock loop circuit without a transformer coupling. Let's see what happens. I couldn't do this before when I was doing the matching chokes, but I can do it now that I'm coupling with a transformer. I'm having a deja vu moment right now. I just don't remember how it ends. You're watching the tank circuit. You're watching the voltage across the tank circuit as the phase lock loop does its initial sweep. You're seeing the tank circuit go through resonance and then lose resonance. It's not locking on the resonance point. That's the problem. When it reaches a peak, that's what we want to lock on. So when I apply power to the phase lock loop circuit, it starts at a high frequency and works its way down to a lower frequency. And as it sweeps, channel 1 is looking across the tank circuit. Channel 2, which is the next one down, is looking at the feedback. So when it sweeps, right? If I just look at channel 1, move that down to the center, I'm at 10 volts per division. Let's go to 20 volts per division. And even goes higher than that. I need to go to 50 volts per division. To see how high it peaks, which is what we're after. All right. I'm seeing it peak at 180 volts peak to peak. Or 90 volts peak times 0.707, 90 times 0.707 equals 63.63 volts RMS, divided by a tank impedance of 0.29 ohms. All right, so you're seeing it peak as it sweeps through. You're seeing it peak at 220 watts. There. I cranked it all the way up. I got 30 volts in. I'm peaking at 100 volts. So 100 times 0.707 is 70.7 volts. Watts equals E squared over R. So 70.7 squared that can't be right. That can't be right. Hold on a second, folks. I'm making some kind of error here, big time, and I'm not sure if I'm showing 5 volts per division or 50 volts per division at this point, so I'm going to double check. Okay, we are seeing 50 volts per division. Install toroid on copper pipe and steel in the core. Well, that brings up an interesting point. If I install it on the copper pipe, that would in effect be a current transformer, which is 90 degrees leading or lagging, I'm not sure which, depending on what phase I select. So let me attach channel 2 to the current sensing transformer on the primary input side of the transformer and see what kind of signal I get. If I'm not mistaken, it should start strong and then dip, but it doesn't. What do the caps do once it rises to peak? Not sure I understand the question. Yeah, you see it peaking. White star is correct. They resonate with the coil. That's why it's peaking. And that's where you get the highest circulating currents in the tank circuit. Well, I don't want to short out the coil. All right, so there's the screwdriver inside the coil. All right, so right there, I just adjusted it manually. There's my current lagging the voltage by 90 degrees. So here we're looking at the current transformer superimposed onto the voltage across the tank circuit. And right now my tank coil is getting a little warm. I don't have any water flowing through it right now. What I've done is manually adjust my frequency. I'm going to try feeding that current transformer as my signal back to the phase lock loop and see what that does. Just for shits and giggles. No, that's not a lock. Or maybe it is a lock. No. That was drawing quite a lot of current, though. And my capacitor was getting nice and hot, too. So I got a lot of circulating current going on here. All right, I think it's time to hook up my circulating water here. This is not a real lock. For some reason, it's ignoring the signal coming off the current transformer completely. It's just ignoring it. All right, this is my supply line. My return line. Whoa. Whoa. Holy crap. These wires were starting to melt together. Wow. Time to use heavier gauge wire. I may be breaking out the 4 gauge in a minute. Wow. Are you kidding me? Separate the wires, don't twist. The reason I twist is to eliminate stray induction. I'm not even going to answer that question. But the induction is heating the wires. Exactly, so I want to cancel the induction in the wires. The only induction you want in the circuit is at the work coil, or yeah. Come on, get off of there. power. No, it's not locking at all. Shit. I'm getting really flippin' annoyed here. I mean really annoyed here. Not that I'm aware of, Gary. I've checked all the MOSFETs. All the MOSFETs are fine. I've got large circulating currents around the tank here, though. Need to have a lot of capacitance right at the MOSFETs. Very low impedance here. Yep. Very high circulating currents. Even my I don't know if it's just 10 or 8 gauge wire. I think it's 10 gauge. This 10 gauge is getting hot. I'm thinking one of my tank capacitors might be shorted. I hope not, but I think one might be. So I need to figure it out. Shit. Well, let's find out. If I have a shorted tank capacitor, it would explain a lot of things. And I do not have a shorted tank capacitor. That would have been too easy. And I've got a total of 10.5 microfarads of capacitance. So that's not it. This is discouraging. There's got to be something really simple that I'm doing wrong with my phase lock loop. Some minute detail that I missed. Caps were only slightly warm. And they were evenly warm. No bulgers, no. Last time it was capped to pin 14, yeah. I started with 0.1, that worked for a while. Then I went to 0.01, that worked for a while. Then 0.01 stopped working. I'm now back to 0.1 microfarads to pin 14. Z, so if lock So if lock the image of the scope to sweep to maximum and stay there. Often PLL circuit requires a slight back off on the peak when adjusting. Yes, it does, but I need to find the peak first. Those times when I was able to achieve a lock, surprisingly, miraculously, I was able to go slightly off peak to the high side, which is slightly inductive load to the MOSFETs, which is what they like. And everybody was happy. I don't know. This is very frustrating. Very, very frustrating. And DirgeBot, if you're still watching, I'm using transformer coupled parallel driven right now. I wanted to just try it, although I'm getting significant heating on the secondary of the coupling transformer. I need a break. Well, there is a school of thought, Otoria, that says you need to limit the frequency bandwidth of the PLL circuit, meaning limiting the sweep range of the PLL circuit, the high and low frequency max, to help it lock. Other schools of thought say no, let it sweep as wide as you can get it, so that you can achieve a lock on in virtually any situation. I don't know which school of thought is right, but I've tried them both, and in my circumstance, neither one works. So, I'm back to the drawing board. quite literally. After dinner, I might come down and try the impedance matching transformers again. Because this parallel driven transformer coupled design is entirely experimental. I don't know if this would work, or if this is the cause of my my pain and suffering right now. But I do need to keep in mind that this configuration is a configuration that I have not seen anyone use online. I've not seen any published designs using this method. If you're transformer coupling, you're always coupling in series with the resonant tank. If you're reactive coupling, then you're coupling in parallel with the tank. I tried transformer coupling in parallel, and this apparently was a crash and burn. So I'm not going to throw in the towel just yet for today. After dinner, I will be back for some more pain and suffering, and we'll see if we can't get this thing to lock. The other change that I made was that change to bring up the output state at pin 13 to 1/2 of the input voltage from the tri-state output. All right, that's it. I'll be back. And of course you didn't hear anything of what I just said. I just happened to say that delivery on that item Thursday, February 23rd to Wednesday, April 5th. So be prepared to wait over a month minimum to get that thing in from Hong Kong. Number one. Number two, I don't believe that they work all that well anyway. Those little cheap jobs. I have seen a couple of them reviewed, but I have my doubts.